Now it's westerlies. Second is westerlies. Why are they named so? Because they start moving or from west side, means they are originating at the west side. That's why they are named so westerlies. Okay, and here I have shown you one more diagram that we have cell, and second one is our Ferrel cell, both in northern hemisphere as well in southern hemisphere, and I'll be explaining you each and everything about the northern hemisphere. You can easily correlate it with the southern hemisphere also. Okay, so Ferrel cell, it is found between the latitude of 30° north to 60° north. Okay, what happens here? The wind starts moving from first west side. It's originating in the western side, so it's known as westerlies, and it start moving from high pressure belt towards subpolar low pressure belt. Okay, so it's start moving like this. Suppose this is the western side and this is the high pressure area, this is low pressure area. So wind start moving from west side of the high pressure area towards the low pressure belt or polar low pressure area. Okay, so this is the direction of the wind. Westerlies are moving like this. And why it happens? Because as you all know that at subpolar region, low pressure area is maintained or low pressure latitude is over there, due to which the wind is rising up, and it's rising up like this and it's getting deflected towards polar region. Okay, and to fill that gap created by the low pressure area, the wind from the westerlies of subtropical high pressure area, they blow towards the low pressure area. Okay, and this cycle continues. Like Hadley said, this cycle also continues in the Ferrel cell and the from the western side. That's why it's known as westerlies. Okay, so here you can see they flow in the Ferrel cell 30° north to 60° north in northern hemisphere, and same in the southern hemisphere. They flow from subtropical high pressure belt towards subpolar low pressure belt in both the hemisphere. Yeah, their direction. Okay, here you can see that they are originating from southwest to north in the northern hemisphere. Here you can see they are moving from southeast towards the northwest in the northern hemisphere, and from northwest to southeast in the southern hemisphere, and because of one region, Coriolis force. Okay, yeah, I have told you one thing earlier in this topic, that there is only one difference, and that comes in westerlies. That, as you all know, northern hemisphere, most of our continents and landforms, they are found in the northern hemisphere, and in southern hemisphere only few continents are there, like Australia, Antarctica, some part of the South America, some part of the Africa. So southern hemisphere is dominated by the ocean area. Okay, there is no hindrance or there is no landform as a hindrance in the path of the southern westerlies. So what happens here? They become very strong because there is no hindrance, so they blow with a very high speed in the southern ocean. Okay, what happens here? Okay, at different latitudes, they come with different speed and they make different noises, due to which they are named differently. For example, here you can see roaring 40s. Roaring 40s means they are blowing at between the latitude of 40° south to 50° south. Now their speed is increasing and they are becoming more and more furious. So they are named as furious 50s. Furious 50s means they are moving between the latitude of 50° south to 60° south. Now their speed is becoming more and more high and they are sounding like someone is screaming. That's why they are named as screaming 60s. And they start moving at the latitude between 60° south to 70° south. Okay. So this is that, the direction of the wind, the origin of the wind, and why they are named differently in the southern hemisphere, because there is no hindrance, there is no landform, so their speed increases at different latitudes, and according to that they are named differently. So this is all about the westerlies.